Today's lesson is introducing the Pythagorean Theorem. And to start, we're going to start with a quick review about what we already know about triangles. Then we're going to add one more thing about triangles, which is the Pythagorean Theorem. We'll talk about it's one of the most famous equations of all time. We'll go through some vocabulary that you need to know about the Pythagorean Theorem. We'll have a visual proof. It's the one that's actually used by Pythagoras. And then we'll practice on how to use it. Alright, so quick review. What do we already know about triangles? Well, we know something about their angles, and that is, we know that the triangle angle sum theorem says that the sum of the measures of the angles of a triangle is 180 degrees. We also know something about their sides, and that is the triangle inequality theorem, which says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So we already know some things about triangles. Now we're going to add one more. And that one we're going to add is for right triangles only. Now this is something people often get confused about, but the Pythagorean theorem doesn't work for every triangle. It only works for right triangles. That is, a triangle that has a right angle in it. And what it says is that the sum of the squares of the two smaller sides, which we call legs, equals the square of the longest side, which we call the hypotenuse. And here it is visually. So you can see is that if I figure out the area of that blue square and that red square and add them up, it's going to be the same as the area of that purple square. Because a squared plus b squared equals c squared. Now, it turns out the Pythagorean theorem is a very famous equation. In fact, it's probably the second most famous equation of all time. The most famous equation of all time is E equals mc squared. And the second most famous equation is a squared plus b squared equals c squared. This is from a website you can see below. What are the most famous equations? So let's do some vocabulary so we're all talking about the same terms. A triangle with a 90-degree angle is called a right triangle. In a right triangle, the side that is opposite the right angle, the one that's as far away from the right angle as possible, and it's also the longest side, is called the hypotenuse. In a right triangle, the other two sides, or the sides that are next to the right angle, are called its legs. And finally, if we have three integers such that a squared plus b squared equals c squared, then these integers together are called a Pythagorean triple. And there are lots of Pythagorean triples, but there are three that you should really memorize, and those are 3, 4, 5, because again, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So 3, 4, 5, 5, 12, 13, and if you're feeling like it, you can remember 7, 24, 25. We'll talk more later about why it's so important to memorize Pythagorean triples, but for right now, if you can just remember 3, 4, 5, that's a good start. Now here is the proof that Pythagoras used when doing the Pythagorean theorem. Of course, he didn't have a computer and a movie to play with, but right here I have a right triangle, and you can see I have 4 of these right triangles right here. I've stacked them up. And over here I have a square that's a on a side. So this piece right here is a squared big. Over here this is b side. And so this black space here is b squared big. Now if I push play for a second and move these triangles over, you can see that now I'm at c squared. So a squared plus b squared equals c squared. Obviously, the amount of black area is moving around, but the sum total isn't changing. And that's c squared there, and there's a squared plus b squared. And so again, a squared plus b squared equals c squared. Okay, now that we know what the Pythagorean theorem says, our objective is to solve problems involving the Pythagorean theorem. So for right triangles only, if I have a triangle, and I know it has a leg there, another leg here, and its hypotenuse is here because remember the hypotenuse is always opposite the right triangle or the right angle. Then I can call one leg A, another leg B, and my hypotenuse C. And it doesn't matter which one I call A and B. I could flip them around and call this one A and this one B. It doesn't matter. As long as hypotenuse is C, the other two could be A or B. It doesn't matter. Now the Pythagorean theorem tells me that A squared plus B squared equals C squared. Okay, so let's do an example. Find the missing side there of x. So what I know is that A squared plus B squared equals C squared. So let's plug it in. I can see that x is going to be C because it's across from my right angle. It's the hypotenuse. So A and B are 30 and 40, and again the order doesn't matter. I'll just call 30 squared plus 40 squared equals x squared. Solve that out. That's 900 plus 1600 equals x squared. Add those up. 2500 equals x squared. Take the square root, and so I know that x equals the square root of 2500, or x equals 50. So that side right there is 50 meters. And I solved it using the Pythagorean theorem. So that's one type of problem we can solve, is finding the missing side. A second type of problem we can solve is to determine if a triangle is a right triangle. So here I have a triangle over on the left here. And again, I'm going to put A, B, and C on. A squared plus B squared equals C squared. And I know that my hypotenuse, if it is a right angle, is going to be 29 because the hypotenuse is always the longest side of a right triangle. So I'm going to plug in 20 squared plus 21 squared. Is that equal to? Is it true that that's equal to 29 squared? Well, let's find out. So 20 squared is 400, and 21 squared is 441, and 29 squared is 881. Are those equal? If I add them up, I get 881. Is that equal to 881? And of course the answer is yes. Yes, it is. So since I know that A squared plus B squared equals C squared, therefore I know that the triangle is a right triangle. Now, finally, a word about Pythagorean triples. I said that you should memorize 3, 4, 5, and that's because it shows up all the time. Not only does it show up as 3, 4, 5, but the multiples of 3, 4, 5. So I multiply them by 2. 6, 8, 10 is a Pythagorean triple. Multiply by 3, 9, 12, 15. Multiply by 4, and so forth. This goes on forever. But if I can find 3 sides in the ratio of 3, 4, 5, they'll be a Pythagorean triple. Next one that you should memorize is 5, 12, 13, and similarly again I can multiply by 2, multiply by 3, keep multiplying by whatever. And the final one I said I think you should memorize is 7, 24, 25, and again multiply by 2, multiply by 3, it just keeps going. Now the benefit of doing this is that it makes solving problems significantly easier if you can quickly see the Pythagorean triple. So imagine I'm given this problem, and I see my hypotenuse is 15 and my one leg is 12. Well, I could, if I divide both of those by 3, I see that the hypotenuse would be 5 and the leg is 4, so the other leg would be 3. And if I divide it by 3 to multiply by 3, I know it's 9. So it's equal to this Pythagorean triple right here of 9, 12, 15. So my answer is simply going to be 9. And I didn't have to do A squared plus B squared equals C squared, didn't have to multiply, didn't have to do anything. All I had to do was remember that 3, 4, 5 is a Pythagorean triple. And that makes my life much, much easier solving these sorts of problems.